will restart this browser.
His last words.
Oh, we can do the fun thing of me sharing a screen, and then it looks like this. VLC.
So there's no way to sort of put yourself in the queue for speaking, or?
Oh, sure there is. There's right where you asked for, one to the left of where you just started sending the audio. There's a request audio queue, or at least there should be.
I don't see the queue itself, do you?
I don't know.
I see you in the queue now.
I see you in the queue, but if there's no one in the queue, there's no queue to see.
Mm-hmm.
So like I can join the queue and you can see what that looks like.
So if I did this, are you seeing the slide all over everything? Because I made it full screen, so it's hiding the Chrome. Can you see the slides now? Anyone?
Seeing the application that would present the slides, but it's still in the not full screen mode. So we see the list of slides on the left and the note well from the second slide as well as the first slide.
So clicking presentation doesn't do anything. Okay, that's good to know, I guess. I could do it like this and then make this disappear and enlarge, and that's sort of better. But I'll think
that works pretty well.
Yeah, I'll let Taro sling the slides when he gets back.
Okay, I'm back. I will try to, if you can.
Okay, I'll stop sharing. Okay.
Okay. So you are seeing my slide now?
Oh yes.
Okay. Because I'm not seeing any video still, so I can't see I can see my slides on my screen, but I can see them on the browser, and I can see yours video on the browser. I can see that there is a video that is supposed to be there, but for some reason it doesn't show. Anyway, I can live with that. I don't need to see the slides. I can see them from my screen. But if something goes wrong with them, you need to tell me that if it's not showing anymore.
Okay, I think the session is started, so let's get on with it. We go to the next slide and show the note well. And even though the font is really, really small, it doesn't really matter because we're all remote, so we've all got our reading glasses and we're seeing the small font just fine. Okay, so note the note well, and let's go on to the blue sheets are automatic here. Just by logging into Meet Echo, you register on the blue sheet. So we need a JabberScribe and 2 note takers. And the links, at least to the note taking, are on the agenda. Do we really need a JabberScribe? What does a JabberScribe do in a virtual meeting?
The problematic thing is that you can't see that if you are, going with the queue, you can't see the chat unless you have a Jabber client, separate one. I have a separate Jabber client, so I can actually see what's happening there, but But Jabber scribe would be useful to have somebody actually checking Jabber and telling us if there's anything important there.
Yeah, I also have a Jabber client, and we'll try to be paying attention.
Okay, good. So, so we need volunteers for note-taking at least. Anyone? Paul?
Linux set up to not crash out halfway.
Mm-hmm.
That's why we want to have a tool. And we are using the Kodime, or what is the, I don't know how to spell that one.
COVID-19.
Yeah.
Not exactly. CodeMD. Okay, so we don't really need blow by blow, just any decisions made or ideas accepted or rejected or stuff like that.
And I have already pre-filled that one so that it actually has the, all the titles and agenda and so on. So just need to type in what's happening with the discussion and so on.
Mm-hmm. Okay. So can we move on? Oh, we just got Paul. Anyone else?
Oh, there's a couple of people in the Benedict and Timothy in the Jabber saying they can also.
Okay.
So it's a good thing if you have more than one people, because somebody might be discussing at the same time and so.
Right. Okay. Great. Thanks. So let's go to the group status. I think is the next slide.
Oh, agenda.
Right. So we've got all the allocated time for technical difficulties, and this is the agenda. Any comments? Anything we forgot? Missing stuff? Yeah, I remember that Paul had something he wanted to discuss in any other business, but well, we'll get to that. Okay, so anyone? I'm not seeing anyone rushing to the queue, so status. Okay, since we last met, which was in November, and I wasn't there, so Implicit IV got published as RFC 8750, and QR IKEV2 was published as RFC 8784, and I think for the first time in several years, I don't have a draft in this working group. So, yeah. And we've requested publication for the IPv6 and IPv4 codes, and so that's the publication request. And then we've got work in progress for the intermediate, multiple KE, IPTFS, labeled IPSEC, which I don't think we've had much discussion about that recently. And of course, GIKV2, that's been going on since I think the first IETF I ever attended, which was in 2007. So yeah, that's been a long time coming. Yeah, next slide. Okay, so we've got presentations, and the first couple are from Valerie. So next slide. Okay, Valerie, just come to the mic and I'll shut myself up so I don't bother you.
Can you hear me?
Yes, we can hear you.
Okay. Hello, I'm Valery, and I'm going to make a few presentations today. And the first is about update of TCP encapsulation of IKE and IPSEC packets RFC 8229. Next, please. So TCP encapsulation was defined in 8229, published a while ago, and it modifies IKE2 behavior in several ways. There are very quite a lot of places when IKE2 behavior must be accommodated must be handled differently compared with UDP transport. And while RFC tries to cover all these places and prescribe the new behavior, it turned out after some implementation experience that some nuances wasn't covered in the RFC. And some of these nuances are just affect performance and probably very small. But other affect real reliability and interoperability. So there was a draft initially prepared that just lists all these clarifications for the RFC, but following our area director advice and our chair's advice, it was decided to instead to prepare an BIS document for 8229. So Tommy and myself have prepared the draft that can be used as initial version of this document. Next, please. So here I will try to cover just differences that are not addressed in the current version of in the current RFC and that must be addressed in this draft. So first about retransmission. So IKE2 requires exchange initiator to retransmit request periodically. And TCP is a reliable protocol, so retransmissions are not needed. And moreover, excessive retransmissions may make things worse, because in case of congestion, requests that will be done by IKE application will increase this congestion, making things worse. But in some cases, for example, if TCP connection is lost and then restored, then the transmission must be sent. So it is not covered in the RFC, it must be added to the draft. Next, please. Next thing is about using cookie and puzzle. And in general, cookie is not useful with TCP because TCP verifies that it's stateful protocol and it initiates connection, and it verifies that the P address is real. So there is very little sense to use cookie. On the other hand, puzzle can be used because it provides a different mechanism to defend against distributed denial of service attack. And so cookie will be used only if puzzle is used. But of course, if cookie is requested by initiator, responders still need to handle it in this TCP. So next, please. Another thing is error handling in the IKE init. So since UDP is unreliable transport, RFC 7296 advises initiator not to act immediately if it receives some error notification in the IKE init, but wait for some time because this packet can be forged. But in case of TCP, it makes little sense because either we receive the error and it is a genuine error, or it is forged. But if it is forged, the TCP connection is hijacked and the genuine error will never be received. So it must be also addressed in the revised draft. Next, please. Probably most serious issue with the current RFC is an interaction with MOBIKE. And there are a couple of things that are important here. First, NAT detection IP contact must not be currently, RFC recommends that if IP changes, that initiator first tries to connect over UDP and then switch to TCP. And with TCP, the NAT detection IP notification must be recalculated if source address ports differ from UDPs. And that's just to detect whether another place is present. So at the same time, message ID for TCP-based exchange must remain the same, even if we switch to the different transport. So the next, please. And another very important thing is the interaction with high availability clusters. Since TCP connection, when cluster is switched from passive to from active to passive node, the TCP connection will most probably will be lost, because well, if it survives, we have very reliable clusters that duplicates TCP every TCP connection, but it is in most cases it is not realistic. So when TCP connection is lost and the responder, so the cluster, the initial responder, have something to send, it cannot do it. So at the same time, the initiator and it must send, because according to RFC 7311, it must send a special packet informing that message ID must be adjusted and sequence number must be adjusted. But it can do it because TCP connection is lost and the initial responder cannot restore it. It has no means to do it. So the advice is that client should periodically send liveness check messages, and it must do it more frequently and despite whether real traffic exists or no. Despite if there is a traffic, it must not send. But if there is no traffic, it must send periodically liveness checks that will restore TCP connection in case the cluster is switched to the backup node. Next, please. So that's basically most of the changes. There are more changes that are less important, or probably that can be ignored, but that was covered most of the changes that are in the new document. So we're definitely looking for adoption of the document followed by ROID advice. So what the chair think?
Yes, Paul.
So just a few comments. I'll have to take a closer look at the draft, but I think there should probably also be a section about the kernel requirements and things like what to do when you have like packets that are too small that are smaller than a non-ESP marker, because we had a few bugs when we were implementing this in the Linux kernel. And I think those would be good to also incorporate into the document.
Yes, there is a section that is concerned with IPsec. So how TCP encapsulation is influenced IPsec processing. It is currently a bit short, but it definitely should be expanded. In particular, it says that, for example, you cannot have a multiple, you cannot copy course class field from inner IP header to the outer IP header, because TCP, all the TCP, in the TCP stream, all the packets will have the same course class. It's, for example, one application of TCP on IPsec. And sure, this section must be expanded. I agree.
And then one last question. So I know we did some interrupt testing. Have there been any other vendors yet who've done interrupt testing?
I believe so. Well, initially, when the RFC 8229 was implemented, I remember that we had tested with at least Apple, and as far as I remember, with Cisco as minimum.
Okay, I'm not sure how to remove myself from the queue.
I can do it for you, but you've got a button for stopping transmission. Any other questions? Okay, let's take a hum about how many people have actually read this. So go to the hum tool tab, virtual hum tool tab. It's right next to the chat, right left of the chat. And when I click the start button, you will have a chance to say how loudly you want to hum. So hum now if you have read the draft. Oh, that's going to take 30 seconds. Okay. We'll give you a good long time to decide whether you read the draft or not.
By the way, if you don't want to hum, just don't click anything.
Oh, and actually, if I remember correctly, it doesn't really matter because it just tells me how loudly people hum, not how many. Okay, so yeah, people hummed very softly, pianissimo. And that's really not very helpful.
It's relatively new, so that's probably the case.
Yeah. So if I ask now about how many people haven't read the draft and I get that it's forte, it doesn't really say anything because it doesn't show me how many people hummed. So that's pretty useless. Okay, so since we can't really pull the rule for how many people have read the draft, there's also no point in, well, perhaps there is a point in asking about adoption, or rather, let's ask the participant to come to the queue and say if you think adopting this is a good idea. Yes, Paul.
Hi. So I think it's a good idea to adopt. There were definitely, while we were doing interop, there were definitely some unexpected issues, and I think that would be sad if that knowledge is lost, and I think it should be incorporated into the draft.
So you have a general sense that RFC 82, was it 29, is an incomplete specification for doing IKE and IPSEC over TCP.
I think so, yes. Based on our implementation and the mistakes or the omissions that were made in our implementation, I think so, yes.
Okay, so the question we really would like to ask is if we need an update to 8229 and if this is a good starting point. And I guess that's a question that we will ask on the list. So anyone else?
This is Tero Kivinen. I think actually, if I remember correctly, our original charter was like TCP encapsulation clarifications, and then we decided to do the BIS document, and I think that's the real question now. That.
So the question is if this is a good starting point.
Yeah, and I think we should probably take it to the list.
And yeah, we'll definitely take this to the list. Okay, so if nobody has anything else to add, then I guess we can move to Valerie's second slide deck.
Yes, it's a new item for us. It is called IETF configuration for encrypted DNS. So this work was initially initiated by Matt, Tiro, and Dan, and I was later joined just to clarify things concerning with IETF. So the next, please. So this is just a content of the presentation. It's a simple sample use cases, how it is integrated into IKE, and what next step. So next, please. A description of the problem. So recently several schemes to encrypt DNS have been specified. It's DNS over TLS, DNS over DTLS, DNS over HTTPS, DOH, and another scheme that is currently being specified, DNS over CLIC. So it's quite popular topic currently to make DNS encrypted. And the question is how to securely provide clients with the configuration of encrypted DNS, and so that can use it even within IPsec tunnel. So the next, please. There are a couple of use cases just to illustrate the problem. The first use case is DNS offload. So VPN service provider can offer publicly accessible encrypted DNS outside its domain. So the DNS server is not accessible, or probably maybe or may not be accessible via VPN tunnel. So in this situation, we have to, since DNS is encrypted, it's protected, but we have to configure client to with configuration of how to use it encrypted DNS outside the tunnel. And the next use case. Next, please. It's protecting internal DNS traffic. So recent research, recent trends treat even internal hosts in the protected networks as susceptible to be attacked. And so in this case, encrypted DNS can benefit so that the DNS traffic is encrypted even inside the protected boundary. So so-called zero trust architecture. So the next, please. So how to solve this problem? And we use a new IKE configuration attribute to convey information concerned with encrypted DNS from server to the client. It's called internal DNS, and it has the following information inside. So the type of encrypted DNS, either it is dot or probably doc over quick in future. Currently, it is not yet defined. The scope of DNS use, whether it is intended to use only inside the plain tunnel or also outside the tunnel, and the server address itself, and the encrypted DNS domain, fully qualified domain. So this attribute is exchanged in the IKE exchange along with the other attributes in configure request, in configure reply, in its configuration panel. So the next, please. So the attribute format is denoted in this picture. It has 1 bit that defines the scope, 7 bits that defines the type of encrypted DNS, and then followed by the number, one or more IP addresses for the DNS server. All addresses are encoded as IPv6 addresses, and IPv4 addresses are encoded using the mapping from IPv4 to IPv6. And then DNS authentication domain name. So that's quite simple. So the next, please. So there is one subtle thing that this draft interacts with Split DNS IKE Extension. Currently, RFC 8598 Split DNS configuration for IKE2 requires that internal IP DNS attributes be present when internal DNS domain is included. Since these attributes include both address and domain, so this requirement is relaxed if this draft is implemented. So the next, please. So next steps. I think from conversation with my co-authors that this group is not considered as a primary home group candidate. So they wanted initially the draft to be adopted and progressed in the ADD working group. But since this is concerned with IKE, I think it is of interest for this group. Probably IPSECME can be home for this draft if the group decides that it is of interest. So what's your opinion? Thank you.
Yes, Paul. Paul, can you speak up? We're not hearing you.
Oops, I had another mute button. Sorry. So I think the draft's good. My only concern is with the bit that says something about what to do outside of the VPN tunnel. I think that's sort of out of scope for IKE to say what you should do outside of the VPN. So I think it should. I agree it should define, like, these are the DNS servers you can reach on various protocol flavors. But I'm not sure if it should say something about, oh, and here's some information that you can use. Even if the VPN is down, then you can use this. That seems a bit scary to me and out of scope.
Well, I cannot immediately comment on this because it's mostly, I'm not expert in encrypted DNS, so that my colleagues will probably answer better than myself. But as far as I understand, they feel that this is a very interesting scenario when the DNS initially is offloaded outside the VPN provider, so that all the DNS queries are encrypted, but the DNS provider is different from the VPN provider. So that's an interesting use case.
Okay, I had a couple comments. So the first one is, I think you already noted that there is the ADD working group that is chartered to do things, at least in this space. So we should be sure to have the respective working group chairs coordinate to make sure that we have one proper home for the work. But I'm sure we can do that. And my other comment was that in the slide with the attribute format, you were showing the IP address and the DNS authentication domain name. But my understanding is that for DO, you have to provide a URI template and not just the
exactly. DNS. Thank you. First, about the first question. This presentation was also requested to be done in the ADD working group in this IETF, but because of very tight agenda, the ADD working group chairs decided to not to grant this presentation, this particular presentation, but they are aware of it, and the ADD working group is the primary target home working group for this draft. And for the second question, so the next slide, please. And next, there is a backup slide. Well, there are some doc specifics that are not covered in the draft, and that because this is it is a bit outside of IPSEC, we decided to make this a backup slide and not to present it initially. So exactly for the doc, you have to somehow know URI templates for the doc services. And as far as I understand, it will be covered in details in draft BTV, ADD, RFC 8484 clarification. But the idea is that there is a well-known URI where these templates can be discovered. So.
Yeah, we'll definitely have to follow that work to stay on track. And of course, when DNS over Quick arrives, we don't know yet what kind of configuration it will need.
Yes,
so
sure.
Just to make sure that our attribute format is sufficiently flexible that we can extend to new types of data if we need to. But yeah, I think this is interesting work.
So so you would be saying that instead of having this kind of thing, we probably should have, sub attributes inside that thing, that we could have a multiple different type of things, especially if we see that there's going to be perhaps need for other type of configuration attributes for different types of things we are configuring. Or the other option, of course, is to make multiple because we have this list of configuration attributes already, so we could just do it so that we move this one level up, like we did for IPv4 and IPv6. We have a different payload for IPv4 DNS addresses and different for IPv6 DNS addresses. We could have one format for DOT, one format for DAOH, and one for a quick, because we have a 16-bit attribute type there.
I understand, but we tried to simplify things and to come up with a single attribute just that can be used.
The question is it simplifying or not? Because I think that
Sure.
if we have one level of interaction, one level of listing or nesting already up a layer, and we have a 16-bit, so we can actually we can allocate multiple of those attribute types for different things. So it's just having less internal structure and more of the using the already existing higher level structure.
Okay, so this is Yavnir speaking with no hats. I admit I haven't read the draft, but just looking at the presentation, I think there's something missing in the motivation. Because the big motivation, as far as I'm concerned, is that the world, or at least the world in the IETF, is moving to encrypted DNS, and we don't want to have to keep the old unencrypted DNS just for the sake of the IKEv2 server that doesn't know how to handle encrypted DNS. So we need it, if for no other reason, we need it to keep up with the times, because we don't want to force people to keep the unencrypted DNS.
It's one of the reasons, because as of course, Chiro probably will comment better on it, but as far as I understand, many browsers will soon have an encrypted DNS turned on by default, and they will display a warning if you use an encrypted DNS. So we should be prepared with this, with IPv2, so that users don't see this warning when they use, I don't know, IPv2, IPsec to connect to the VPN provider.
And with that, we have two other people in the queue, so let's hear from them. Please just state your name before you ask your question.
One of the co-authors of the draft. The DNS authentication domain name can be used by all the three flavors of DNS encryption, both DNS over TLS, DNS over HTTPS, and DNS over QUIC. DNS over HTTPS, or the next HTTPS 3, require a URI to be discovered, and that URI discovered can be done securely using a well-known domain name. So that is, the client first establishes the TLS handshake and then uses the URI to retrieve the well-known URI to retrieve all the DWORD services. The services could be like, I can do malware filtering, I can block phishing sites. So the various services, I don't need any filtering from the DWORD service. So those are the various flavors of DWORD URI that could be discovered by the client, and the client can decide to pick whichever service it wants to use from the DWORD server. That discovery is already discussed as part of
Okay, Valerie?
Sorry, the connection was lost.
Okay, so
and I think that is a call because Chiro is closer.
The URI services can be discovered using the well-known URI link, and that's already being discussed as part of that. That's the reason it's not covered in this way.
So if I understand correctly, the comment is that the URL can be discovered in some other way and we don't have to send it explicitly?
Yes.
I see. Okay, so I guess that's something that Valerie needs to discuss with the ADD people. Okay, so next one in the queue, Benedict.
Okay, so maybe this was the context of the previous question, and I just didn't quite catch it. My understanding was that for some DNS services like DNS over TLS, we need a host name to do certificate validation. Is that the same context as the previous question, or if not, is that something that we maybe can just send a string and then do the DNS? We would have to do it. We would have a bootstrapping problem, but we would be able to validate.
Yeah, the ad working group is currently only discussing certificates which are PKI based. We're not discussing any certificates which are using private CA or raw public keys. So that's the reason in this draft we are only covering authentication domain name, because the certificate would have that, and the client would still use PKI to validate the certificate.
I see. Thanks.
Any more questions? Okay. So, Valerie, are you right now calling for adoption of this, or what?
I think that the ADD working group is a primary target home working group for this draft. So,
Well,
as far as I understand from my conversation with Tiro, so it's probably in this working group is just for information. But if there is an interest in IPSECME working group for this draft, I think that it can be persist in this working group instead. But not right now. Not calling for adoption right now.
Okay, good.
Yeah, I think we need a couple of more revisions for this draft before I think it's ready. But we would definitely like to present this draft in ad working group as well, and we would like the chairs of both this working group and ad to coordinate. And because this is an extension to IKE, it definitely falls into this, but chapter as well. But ad working group will also be aware of the work that's happening here. So I guess some discussions have to happen in both the working groups. So we wanted to make sure that both the working groups are aware of this work, and we don't want it to be developed in isolation.
Okay. Makes sense.
Yeah, just this has been Kalex to note as the area director, if this working group, IPSECME, decided to say that this work is terrible and you shouldn't do it, that would be very useful information for ADD to have. I don't see that happening, of course, but to be able to say that we saw the work and it seems to make sense is useful information to have.
Yeah, and one comment to add is currently, if you see, most of the drafts that are discussed in ad are basically using insecure mechanisms to discover the DOT DWORD servers. Either it could be DHCP, routing advertisement, or it could be a domain, especially assigned domain name which the client queries in DNS 53 to retrieve whether the network supports DOT or DOH. This is the only only secure mechanism that's being discussed, which make sure that it's not an attacker who is providing a DOT device server rather than it's the server which is hosted by the VPN provider. So that makes it quite unique and probably different from a VPN use case compared to the other cases that's being discussed in ad working.
Okay, so with that, let's go to Valerie's third and last thing, because we're already about 7 minutes behind schedule. So
I'll be
on.
fast. So announcing supported authentication method in IKE2. Next, please. So you know that unlike IKE1, authentication method in IKE2 is not negotiated, so that each PA is free to use whatever it thinks is acceptable, is appropriate. And generally it works. It works well if there is no ambiguity in selected in choosing among the several methods. But if PAs can use several methods to authenticate each other, so that it is possible that initiator selects authentication method unsupported by the responder. The next, please. And the problem that we encountered a few years ago when RSA PSS signature format appeared in IKE2. New initiators tried to use PSS signature, while all the responded didn't support it, sending back authentication failed. So, of course, if initiators knew responders' capabilities, they would have chosen PSS 1, and they say succeeded. So the next, please. And sources the problem that currently there is no way for peers to explicitly indicate the supported authentication method. There are some heuristic mechanisms that can be done using cert request payload, for example, or ID content, but all of them are unreliable. And I think that with new signature formats and authentication methods, especially post-quantum and hybrid ones that are already discussed in TLS working group, in KIDS working group, there are some drafts. The station of misselecting may happen more often. The next, please. And the proposed solution is to add the new notification, supported house method, to indicate the supported authentication method so that it is an optional notification that each peer can send to each other. And for certificate-based authentication, it's useful to add an ability for the peers to indicate which signing method can be used with each of the three in the set request payload. And another thing that is desirable and to avoid creating new IANA registries for them. So next, please. So the format of notification is a list of supported authentication methods, of which each of them is represented using three possible formats. A 2-octet format for a very simple method like pre-shared key or null authentication. 3-octet format that is for methods that can be linked to RSA to set request payload, and multi-octet format that actually for the currently it's only method signature, digital signature. It contains algorithm identifier to completely identify the signature algorithm that can be used for this authentication method. And the linking is done by pointing to the content of set request payload that is illustrated on the next slide. Next, please. So this is an illustration of how the linking to the set request payload is done. So each authentication method contains a subfield called link, and it contains either 0 or non-zero value. If it is non-zero, it points this value is treated as a number, the sequence number of CAs in the set request payload. If it is 0, it means that this particular authentication method can use with any CAs, or it isn't concerned with it. So the next, please. So how it is exchanged? Since there are two options. Option one is very simple. It is exchanged along with set request payload. So each time the PS sends set request payload, it also includes supported out method. Next, please. The problem with the first option is that supported out method notification can be quite long because the peer can support quite a lot of methods. Since the algorithm identifiers ISN.1 algorithm identifiers included, they can be quite long, several hundred bytes. So in this case, we can use IKE intermediate exchange that is used for other purposes currently for multiple key exchanges. And for example, we can use it for other purpose. So if responder thinks that the size of its response will be too large and cause IP fragmentation, it can send an empty supported out method identification, and that is a hint for initiator that it must initiate IKE intermediate exchange or piggyback if IKE intermediate exchange is initiated for some other purpose. And so is this IKE intermediate exchange, the responder will include its notification. So for the initiator, there's no problem because it includes in IKE exchange. So the next, please. So I try to be very quick. I want to say that this particular topic is in the IPSECME Charter, and we don't yet have a candidate for candidate draft to solve this problem. So I think that probably this draft can be treated as a candidate and can be adopted as such. So thank you.
Yes, Paul.
Hi, Paul Wouter speaking. So I think this draft is a good idea. I'm not sure yet about where all the complexity is needed, but I did want to point out that for Librison, we had a similar issue. We wanted to support null encryption on both sides and then slowly have people be able to migrate to certificates. And we couldn't really signal that. So what we did is we ended up doing a custom a custom payload where we did the PPK trick. And speaking of that, so in that sense, I think doing this in a standardized way is good, and I would support it. I would like to maybe see the PPK hack also merge into this so that we can do this properly with this method, and then maybe in the future, obsolete the PPK auth hack. For those who don't know, with PPK, you basically send 2 auth payloads differently calculated, and then, but with this draft, you could just send the one that you think is needed.
Wait, this is Tero Kynin as a, not chair, but as a working member. I think one of the things we could probably do also, we could actually split this in 2 pieces, meaning one to negotiate the actual authentication algorithm. The other one is the problem that which methods are suitable for each CA, and having the linking back and forth with the certificate payload, certificate request, and so on. That gets very messy. So I was actually thinking about it might be better to have this information you have there in this one, having this information about algorithm IDs to be inside the certificate request itself. So we'd have a list of supported authentication method which says on the PS key signatures and RSA-SIG and so on, whatever formats you have. But the list of suitable algorithm IDs would be inside the certificate requests, meaning that we actually allocate one new certificate request type that has in addition to having the hash of the CA, we also would have an a list of OIDs that it's algorithm IDs it supports or something like that. It would actually perhaps shorten the list or make it a little bit easier to parse. I don't know.
Okay, Scott. Scott, are you by accident muted? Because we're not hearing you at all. Okay, anyone else? Okay, so Valerie, are you looking for adoption on this one?
Yes.
Okay, so like everything else, we'll take it to the list because we're a little behind schedule. And okay, so next slide, too. So now Michael Rosberg is going to do the pitch for improvements, proposed improvements to ESP.
Hi, everybody. So let's take the next slide already. So what we did was we looked at ESP and data centers, and we come into a couple of problems. And we had 2 major issues, and one was that the sequence numbers are not handled in ESP as we want them to be handled. So maybe a pretty subjective view, but that gives us problems with parallelism, and it gives us problems with multicast replay protection, which we see in data centers right now. And it also gives us issues with QoS. There are a couple of ways around that right now being discussed, but it all boils down to the problem that sequence numbers are bound to an SPI, basically. And the other thing that we had was a well-known problem to this group is that ESP trailer forces us to do complex protocol handling. So if we have fragments, if we have segments, and maybe alignment issues, then this trailer comes into our way. And what we did was we exchanged things and messed with ESP a little. And what I want to do now is to give you a short explanation of what we did with it, even though we don't know yet what we can do with it. So what we currently have, we have an implementation of it, but we don't know if that's worth a new protocol, a new version, a different mode, different, encapsulation method. Next, please. So what we did was we kept basically the SPI where it stays, but between the SPI and the sequence number, we introduced another field, or basically two other fields, and they indicate which window, we introduced multiple windows, and for each sender, or if you have one sender, that can also introduce different windows for different QoS classes and maybe for different CPU cores, and then have every CPU core or whatever or sender have its own sequence numbers. And what we also did was we introduced a larger sequence number field. So we basically send always the whole 64-bit of sequence number information, which we have for ESN anyways. But if we explicitly send them with every packet, we don't have synchronization problems, especially if you are talking about having one key in a whole data center and large multipass groups, then we had this synchronization problem. Furthermore, we shifted the ICV value from the trailer to the beginning and in the header, which allows us to make assumptions. For an example, that it's always present in the first segment, or it's always present in the first fragment, and it's all followed by the encrypted packet. What we got rid of is the whole trailer. That means the padding is done now implicitly, like it is done for traffic flow confidentiality anyways. If as long as you do tunnel mode, that's not a problem. If you did something else, that's a different point of discussion, but we don't want to do that here. I want to just tell you today about what we did to the tunnel mode. And so we can get rid of the padding actually, and also the pad length field. And also the next header field is actually not required, because either you send IPv4 or IPv6, and you can just always look at the first nibble. That simplifies packets a lot, packet processing a lot. Next, please. And it allows us to have multiple replay windows per security association. And they're just identified by the sender ID and the window ID, as I said. And it allows us to scale over more CPU cores without having additional things done in the group protocol or in the key management protocol. And it allows us to do multicast replay protection, as each sender can just use its own sequence number window. And it allows us also to do replay windows per QoS class. In this case, the sender just uses different window IDs for different QoS classes, and they can just overtake. What I have not discussed in detail here, but we all use the sender ID, the window ID, and the sequence number as an initialization vector to the encryption. And this allows us to do implicit IV, and allows us to get a little bit more performance, because we don't need additional authenticated data anymore. Anything changed in any field in the header leads to a decryption or failed decryption. Thus, an attacker cannot do that. And without AAD, we can faster encrypt things, because we don't need an additional round, for example, in GCN. And we have also implicit padding. So now I know this is kind of a large change, so that's why I wanted to discuss it before just writing some drafts or have feedback here from the group. What we intend to do is something like, we don't want to replace fully ESP with it, but have it somehow negotiated. If you're running it in a data center or so, then you could use that mode, which is tuned to having fast performant implementations, and you could just do it so by an SPI basis, and you can decide for an example in the Linux kernel if you encrypt it with if the packet was encrypted with that mode or just normal ESP. Next, please. And this is just to show you how much performance you can get from such an implementation. So this is just a measurement we did on a Broadwell CPU, and it shows you different performance figures for ESP, a vanilla ESP, a security association, and that's our approach, which we call VPE. And what you can see is that you can run it at about 30 gigabit per second lines. It's 30 gigabit per second on the read side, so on the unencrypted side, and have pretty much high performance from the approach. Okay, next, please. So thanks for listening. What I'm interested in is feedback from you, so where we can decide on how to incorporate things into a draft, or if we should just have it somewhere. Have it just an information draft, for example, or just that things are not a good idea, maybe also would be outcome. Okay. Any questions?
Valerie's dropped. So I'll see something. There's already a live discussion going on in the list, and I think informational is definitely the wrong thing because they're trying to change on the wire protocol, so that's either experimental or standard threat, but definitely not informational. They're not telling us about something. Now, whether it's a good idea, well, that's already being hashed out on the list. And if you read the Jabber room, or it's also the Mitaco, I think there's quite a bit of discussion right now. And there's there's no consensus about this, but there's a lot of discussion.
This document also, I think this is not in our charter currently, and I think this is actually going to be a little bit bigger change. And so there are so many things people want to do when we start messing up with the ESP protocol. So I think we might take a couple of minutes of very short comments, but I think we need to start working on this in the list first and see if it actually is a good idea. And because I think if we start discussing all the proposals and things we can do, we will take the whole time of the rest of the session.
Right.
But we can take a couple of minutes for short comments if anybody has any comments, or we can just assume that we move to the discussion to the list.
Right. And at some point, maybe we'd want to have a virtual interim about it if there's enough interest. So anyone still want to comment here? Okay, so this is not the dismissive take it to the list, because it's already discussed on the list and there's a lot to say on the list. Okay, so the people who only commented in the Jabber room will take that to the list as well. Okay, so let's go with the next slide. So Christian, and about traffic flow security, and we're starting with the presentation about the thing that is already in the charter and being worked on.
Yeah, hi. Oh, good. It looks like my audio is coming through. Hi, yeah, I'm Christian Hops with Lavin Consulting, and this is an update. Right, it showed on the status slides this was an individual draft, but we adopted this a while back, so it's a working group document now. So next slide, please. So this is an update since 106. We didn't meet in 107. So this was published prior to 107 back in March. The notable changes, these were changes asked for at 106 and on the list. The two big ones were, or the biggest one was the IKE v2. I had used transforms, and Paul and some others said, well, this is a silly way to do this. And yeah, they were right. So let's go to the next slide. So we switched to basically to enable IPTFS, we use a notification. It's the same sort of method as the transport mode. The only thing, the thing that's different there is that we have we added a required flags payload to the notification. If the required flags are not understood or they are or supported, the TFS mode would not be enabled by the responder, or if it's the initiator that's getting back a required flags field that it doesn't support. it would then delete the SA. So, which is following the basic method. Next slide. So the two required notification flags are congestion control. Whether basically if it's set, the sender is asking the receiver to send it back congestion control information periodically. It must be sent. And if the receiver doesn't support sending that information, it would then not set up TFS. The don't fragment bit, this was required a while ago, but we're just continuing to bring that forward, which is if the sender or the notify message does not support receiving fragments. So next slide. We changed the, because we're looking at doing a protocol number, we wanted to make it as generic as possible so that we could really not, have any sort of trouble with this. So we used basically a first octet subtype, which then allows basically for the IPTFS protocol number, we will have 256 uses of different header formats if we needed them, even if they were not TFS. This would be a way to extend the payload types. Next slide. So with that change, then these are the new header formats. Subtype 0 is the non-congestion control payload format. That's a type 0, reserved bits, which this used to be a 16-bit flag field, basically, that was all zeros. And no other changes. Next slide. Congestion control payload format goes to subtype 1, and that did have a flag, which is that whether ECN bits were used in calculating the data that it's returning, and that's the E flag. The rest of the flag bits are reserved, and the rest of the header stays the same. Next slide. Next slide. So we had a couple open issues and comments from last meeting. One was the IP protocol number. We discussed this in the list a couple times. I think we've done discussing it. So we're just waiting for the chairs to forward the request. We've got a summary there of, basically we looked at using what wrap ESP, but it didn't really gain us anything. We still needed the next header number, so that we just were burning some extra bits and bandwidth. So what we had agreed on was to, let's start an early allocation process. This will let us get through any kind of issues that might come up. And, we can deal with them so that it's not happening at the very end of the process. And even if we did run into some problems, which we really don't anticipate that, once we justify the use, but if we did, we can always fall back to overloading an IP protocol number. But this really isn't where we want to start, right? Because, there's already people that are thinking that they might be able to use this framing outside of ESP. And the minute you leave ESP, then you can't just use an overloaded IP protocol number anymore. So anyway, there's a lot of IP protocol numbers. It is an 8-bit field, but there's more than half are left, and a bunch can be deprecated. So, let me come back to that. So the other major thing was transport mode, and we discussed this on the list and decided that this could be done in a separate document. There are some real, it depends on how far we want to go with supporting transport mode. If it's just to support GRE, the Cisco sort of GRE with transport mode tunnel, it's fairly easy to do this. But if you want to get any more generic, you have to start talking about what IP fields to carry, because you're carrying multiple IP packets in each outer IP. Because you'll be creating like pad packets, right? So what IP fields do they carry? Do they carry the last ones? Anyway, all of that sort of stuff can be discussed in a separate document, and that we can move the simpler method, the tunnel mode, forward. So that seemed to go fine. Everyone just wanted to make sure that that it doesn't conflict with the tunnel mode. And basically, since we have the subtypes, we also have flags, and even the mode itself of going in transport mode to differentiate any header changes we might need in the future. Anyway, coming back, throwing it back to IP number, we do have the AD in the room, and the chairs are here. So I'm wondering if we could could we make that official? Maybe I'll leave that question to the very end of the presentation, though. Let's go to the next slide. The other issues that we were looking at was possibly doing an alignment. So I went and looked at this while I've been working on this a reference implementation of this, and what the cons are basically that it complicates the NCAP decap to do alignment between the data blocks or the inner packets in the payload. It also wastes bandwidth. The reason to do it was basically to make it less rigorous white box code to work. Like ASICs don't have a problem with this at all, but if the code is sort of sloppy and tries to pull a length field from an odd thing, it can slow down on some processors. Like some of the old RISC processors used to throw an exception that had to be handled in the kernel. But in any case, what you end up finding is that even when you're doing chained buffers, you end up having to parse the packet to find, you have to parse the packet to find the header, and you're always doing a copy out of the packet header, just because you've already cache loaded it, right? So when I went to find the header, I've already loaded the first 64 bytes of the packet into the cache anyway. So as a way to make, efficiently coding this, you always create the first of the chain. You're copying the packet header in it anyway, so it'll be aligned. That's the key. So you end up without alignment issues, even without aligning the data in the payload. So basically, it just seems like we don't need this, and it keeps things simple. The other thing is that we're still planning to. We've got the VPP implementation that we'll be publishing this year, open source, with congestion control and the IKE v2 changes. And we're also very interested in working with other people and collaborating on other implementations or interoperability testing. Next slide. So we're wondering if there's any more comments, and if we're ready to go to working with last call.
Okay, since no one's at the queue, I'll speak first. So the thing that concerns me about this document is that I don't think it got a lot of review. And yeah, working group last call is one way to get it. But another thing I think we might do is ask for a transport directorate review, early transport directorate review, because they usually have stuff to say about documents like this. And so if anybody has another idea of how we can get more review for this, that would also be great, because yeah, working group last call is one way, but I don't know if it's the best way.
This is I have been, I haven't actually been following the discussion that much, except for the protocol number, and I was there when the WESP protocol number was allocated, and I think you have a very, or it might be that the protocols have changed lately heavily, but at that point it was really, really hard to get the protocol number for IP. We have to fight it, because why do you need two? You already have two, why do you need third one? And that was one of the problems we had at that point. It might have changed. The question I have there is that how many people have actually read these documents? So if people could actually, just type into the Jabber, if you have read it, so we can actually see if there is, enough people to actually be reading this to be able to start working group last call. If you have, only 5 people reading it, there is really no point of starting. Really, we need a bit more people. We see only 1 now.
Well,
that's why.
So I mean, I would be happy with 5 of the experts, right? I did get a feeling that we were getting, some of the experts here reviewing it, but that's just my experience from, LSR working group, right? If you get 5 of your experts, that's a pretty good review.
All right, yeah. So we seem to be having about 5 people who have said that they have read the draft. Okay, we have somebody in the queue.
Yeah, let's hear him. Lou?
Hi, it's Lou Berger. I was just going to say, I don't think getting a protocol number is such a big deal. I went through the protocol list, and there's quite a number that are really old and could be deprecated. I actually talked to someone else who has some protocol numbers assigned to them, and by the way, I have one too, and about doing a deprecation draft. And his response is, why? It's easy to get them, and no one's really going after them. So I don't think getting a protocol number is a big deal.
Okay, so that's encouraging.
Does the AD have any comments about the protocol number stuff? Because I think you are the one who are probably going to be. My understanding is the AD is going to be doing the work anyway, right?
My understanding is also that the AD is involved in making the request. I am happy to send something along. So if we can get a fully filled out protocol allocation, or so if we can get a fully filled out registration template, I'm happy to send that along to the right place.
Well, and thankfully I sent that to the chairs. I'm trying to cover all the bases, so I went to the protocol request form and filled out all this stuff. So
yeah, I think the process is supposed to be that the request is made of the chairs, and the chairs are supposed to send it to the AD, and then the AD will approve it,
right,
and get it to you.
Yep.
Okay, so any objections there for early transport directorate review? Because as far as I remember, and I have read it 6 months ago, it's a pretty complicated thing. It's got a lot of moving parts. So, okay, so with no objections, I'll make the request. Okay, so now we're just 1 minute behind schedule, so we can
awesome
move to the other presentation about something that is not currently a working group item.
Correct. So this is in other working groups, everyone's favorite pastime is to talk about Yang. So a colleague of mine, Don Paddock, who's also in the room to take questions too. We would put together a Yang model to support management of the IPTFS. Next slide. So basically, we have two things: configuration and operational data. The configuration is whether to turn on or not congestion control, the fixed packet size, or and so there's two ways to specify that: either just a fixed size, or to use PathMTU, or the combination where you could say, like for example, we want 1500 octet, but use PathMTU so it could lower it. The other configuration item is the bit rate to send at. So, and there's two ways. We found it was actually more useful to specify the L2 bit rate, because, if I want to use, 100% of this Ethernet or 10% of this Ethernet link bandwidth, people just tend to think more of that, right? I've got a 10 gig or 100 gig link. And then, so obviously the little gray box is saying, the packet transmission frequency is the bit rate divided by packet size. The last configuration is whether to allow fragmentation or not of the inner data blocks. Next slide. So this is what that looks like. I'll get to the model that we're augmenting, but basically this model has an IKE and an IKE-less entry. So for IKE mode, we augment the connection entry under the SA configuration. And this is just the Yang tree, right? So you can see the congestion control Boolean, the packet size, the choice of a tunnel rate, either L2 or L3, and they don't fragment. And then likewise, the way Yang works is you have, the requested config. So that's what the upper one is. The lower one is what it's selected. And this is sort of useful. For example, think about how if you set use PathMTU, but you didn't specify an outer packet size, you would be able to look up in the operational state and see outer packet size, and that would actually be the size that PathMTU had selected. Next slide. This is just the same exact config, but it's in this case, it's in the IKELess module, and so it's under the SPD entry. By the way, that this is actually a grouping because the connection entry used SPD entry, so it used the same. We're augmenting the same grouping basically in IKE and IKELess. In this case, we augment these security association database entry, the SA, basically. For the operational config. So that's what I noted there. It's different from IKE because it's now under the SAD entry. Next slide. So the operational statistics, these are pretty straightforward. We've got the outer IPsec counters, which is basically TXRX, drops and error counts. And then we've got more detail with the inner packets. We track the number of inner packets and octets, the amount of padding that was added. So we break the padding up into two different counters. One is the padding that we added to. So in other words, IPTFS packet that included user traffic, but also padding, that's extra pad. But then there's also times where you're just sending an entire IPTFS payload of pad. So that's what's counted by the all pad. And the same counters for receive. The error would be like a framing format. And the missed is where you've seen a sequence number miss. Incomplete is a similar, it's where you might have missed. If you have a fragment that spanned a couple TFS and you missed part of, missed one of them, that would count as an incomplete in here. Next slide. So this is just those stats underneath in this case, the IKE, it goes underneath child SA info, and then the next slide, you'll see it in the under the SAD entry. In the next slide. Oh, we did. Sorry. So now here's the issue. So the thing is, there's only one active IPsec-Yang model out there, and it's being defined by I2NSF. And as you can see, the name SDN, it's the only active published IPsec-Yang model, so we used it. It is very far along in the process. It's in the IESG publication, so it's still in that process. But if it completes that process, then it's in IETF last call, and then it would become an RFC. But anyway, it's there and it's pretty good. So we augmented that for now. There's also an expired draft. I guess maybe the authors probably worked from that one, but that one is expired, not moving forward. Next slide, please. So the issues with the SDN IPsec model, it basically provides an IKE, an IKELess operation. It also uses an IKE common. So there's three modules, IKE common, used by both of the IKE and the IKELess modules. The IKE module, this is one of the issues we ran into. It doesn't include a security association database. And I asked the authors, and the reason they said was they don't care, because the SDN model is set up to be controlled by a centralized controller, and all they care is that they told IKE what to do and that IKE did it. And that it has a child SA info leaf that holds the connections SA related information. But as everybody in the room probably knows, you've got a connection and it's going to cycle through child SAs and stuff like that, right? But also, it's also missing the SA information, right? It has, my slide is a little bit wrong. It also includes not just lifetime values, but it includes the ESP encapsulation type, right? Like whether there's a NAT or UDP and a few other things like that. What it doesn't include is the selected transforms, right? So you might be specifying a bunch of different possible ESP algorithms, encryption algorithms, but it doesn't tell you which one it's selected. Also, both of the models don't have any counters, on either. So Yeah, I think the IKE list might have some counters, read-only state counters for the lifetime value, but that information is just, that's not provided in the child SA info. You can specify the configuration, but it doesn't keep a running count. These aren't big issues, but the SAD is kind of a big issue. So let's go to the next slide. So we could easily modify this model, but in two ways. We could move the SAD into the common out of the IKE list, because basically just recognizing the fact that, you know, IPsec implementations have a SAD and a SPD, at least logically, whether they're running IKE or not. And if we did that, then under child SA info, you could actually then track the SA that the IKE had created, right? So you would just have a reference to the SA and the SAD. Likewise, the SPD is similar. The IKE creates SPDs. That one's not as big of a deal, I think, but the SA is a big deal. I think it can be moved. Otherwise, you know, late in the game, it's pretty easy to change like the module name. So if you noticed earlier, the module names for these SDN models don't include the letters SDN or I2NSF, right? They just say IPsec common and IPsec IKE. So if they're not going to make a few adjustments to be usable as a base model, I think that we should ask them to add SDN to their module name so that they don't look like they're representing IKE in general. So the next slide, I've got an example of how the change. So the change that we're talking about here is that IKE list basically has an SPD and an SAD, and all we're really talking about is just moving it to the common. And then the IKE list module would just be the notifications. I don't want to get too much into how the SDN model works, but those notifications are critical to running IKE lists, right? It allows the acquire to be sent from the receiving IPsec router to the SDN controller. So those stay the same, but just move the state into the common model so it's shared by the IKE and IKE list. Next slide. I think there's one other change. So what this means is that in the IKE, in the existing IKE model, you just change the the embedded values. You change them to the green, the reference into the common databases. Next slide. So if we're able to make those changes, then IPTFS just augments the common SPD entry. And previously we had to do this in two places. The operational config augments the one SA entry instead of two places. And the operational statistics modify the SAD entry. This was not available under IKE, but now would be, so it would cover both cases. And we would continue to augment the child SA info because this would carry aggregate statistics, right? So, you know, your per SA statistics are going to need to be summed up over time for the connection. Next slide, please. So that's it. So the question that we have for the group is, what should we do? And I will note, Yov is the shepherd for the SDN documents. So curious about your opinion in particular. I mean, do we think it's too late? It's a very small change, and then it's a lot of work was done on this, and it's good work, right? And they could easily serve as base models that we could take forward. There may not be a lot of energy in this working group to do Yang models, right? So I'm just worried that if we pass up this opportunity to make a couple changes and make them useful in general, do we ever end up, or what effort is required to replicate this work?
Well, yeah. On the other hand, the I2NSF working group does nothing but Yang models, but it doesn't have any more energy for anything. So, if you want to make a significant change like that, then it should be either in IETF last call or even get sent back to the working group to make the change. I would guess that the right thing to do is to talk to the authors and see if they're open to add the SAD to the common for in their document. And
yeah, they seem not receptive to that, and I understand why, right? They pushed through to a certain part of the process. Maybe, you know, I mean, but the one thing that's different, I guess, here is that this is the working group that actually understands the change, right? The conceptual change, that moving the SAD from an IKE list into the common really isn't a big change, right? You're moving what module it's under. And the only thing we're really logically saying is that all IPsec has a SAD versus just IKE lists, right?
Right, but for the use case that interests I2NSF or central controller configuring a lot of IKE or IPsec gateways, they don't really need it. So,
so this document, my understanding is that what they are proposed, what they are actually defining is how to configure stuff. Right. So because it's in IKE list, they can configure it. If it's in IKE common, they are only configuring when they are in the IKE list mode. When they are running with the IKE will fill it in. So it's because of this that they actually want to keep, that they probably want to keep it in where they have now. So it's clear for them that they only fill it in and use that to configure at IPsec when they are in the IKE list mode. And if it's in the, yes, both of them have, of course, essays, but when you are using IKE to configure the essays or create the essays, you are not supposed to write the young model stuff and create the essays yourself. But when you are in IKE list, you do that.
Right.
So because it's really configuration, not, you know, reading information about the, you know, what IKE stuff has.
Correct. So I am on a Yang doctor too. So the problem is that that's not actually what Yang is going to do, and that's not what they're specifying, right? Because we have something called MDMA models. Anyway, the point is when you configure something, it's also operational state. So, you know, just saying that, yeah, you know, they're saying that like, yeah, we just want to configure IKE, right? But you know, not having it, just because you didn't model it doesn't mean the information isn't there. And the other thing is that they could easily say, okay, you cannot configure a static SA if you're running an IKE mode. But these are like Yangisms, and you know, I'm not sure if we can make the change, but I also think that maybe we could, you know, I don't know, if we could get some Yang experts to say, hey, you can make this change. You don't really need to send this back through an entire working group process again, right? I mean, that's kind of what I was hoping. I wouldn't want them to have to kick this back and run the process all over again. I think that, you know, the reason to make the change is that, as you might have seen with the Yang versioning, it's not backwards compatible. So if we ever want to reuse this, we can't, right? We have to issue a totally new model. That's the reason I say if we can't make the change, they need to change the module names, because it's misrepresenting that it's, you know, we wouldn't be able, what would we call it? The IPsec real? It's like,
yeah. They're fine with adding I2NSF to their model name.
Yeah, right. I think that's the backup solution. And then I guess we as a working group copy their work and move the SAD, make the one change.
I would really like to have, you know, one young model that would actually cover the IPsec. The reason why we didn't do it in IPSEC-ME, because we didn't have people who would actually be willing to write young models and actually know enough for that. So if you know and can do that and help them to make that young model to be more useful, I would be very happy about that. And, you know, I don't care if it comes from I2NFS or if it comes from IPSEC-ME, but if it's useful for more purposes, I think it would be very useful to have that kind of thing.
I think that we are completely willing to help on that work. We would really want to be using the work they did, though, right, and not starting afresh. So that, I mean, that's why we're bringing this up, is it just seems like such a waste, you know, to waste all that effort to, you know, rerun the entire process for something they've already done, but maybe that's what we have to do, and we just copy their exact modules. The problem is when you think about this from an operator standpoint, having two different modules that are almost identical, but aren't, right? It's just for operators, this is not friendly. For IETF process, maybe it's friendly, and maybe for vendors it's friendly who only want to do like an IoT device or something. But for operators that are actually running this stuff, it's not friendly to have multiple modules that are almost identical. Anyway, I think I'm over time.
This has been KDEC. To note, we had a little discussion in the Jabber that the ITU-NSF document may benefit from having a Yang doctor review at this point, and depending on how that comes back, they may need to make significant changes anyway, in which case perhaps...
Ben, it's already had the Yang doctor review.
For which revision?
I think even the last one.
Oh, okay. I was just relaying from the Jabber. I didn't actually check myself. And there was also some discussion about whether the current version is actually NDMA compliant or not.
Lose the chair of NetMod. He's in the queue.
Okay.
I wasn't going to get chair, but it is true I am. The data tracker state says that it had a Yang doctor early review, not a final review, and it's on an early version. And that one of the comments in there, Martin Dorf did the review. One of the things it comments is it didn't follow the guidelines for Yang models. One of the things that'll happen is it does that, it'll make sure to address all the NMDA issues. Hey Chris, since you're a Yang doctor, do you want to review?
I think I should recuse myself.
Yeah, but according to the data tracker, it needs another review. Particularly because the results of the early review was that the model wasn't ready. So I think you're going to have to clean up that state as it goes through the IESG processing.
Okay, so I don't have a problem with Christian doing the review. Yeah, so we've got another one in the queue. Valerie?
Well, I'd like to draw an attention to GIQ2 draft. And the written draft has received quite a lot of changes. Because, situation with, we decided with discussion with Brian last time, we decided to make it more along the IETF and not another protocol. So now it is more an extension, a large extension, complex extension than a new protocol. So we tried to keep it as much with IETF as possible, and it resulted with a lot of changes. And I encourage people to review it, to read and review, because the draft is huge. And it's difficult to, without any review, it's difficult to make it right, and it's possible that we introduce some errors. So if you have time and interest, please read the review and comment, please. And another point, since that draft intermediate exchange is very long, it's about 1 year without any changes, and I think that a few people has implemented it, so it's close to working group last call, and so people, if folks feel that it needs more reviewing, then please review, but otherwise I think that it's very close to working group last call. Thank you.
Okay, any other business? Yes, Paul.
Hi. So just quick, one comment on labeled IPsec. We're still working on implementing it. So definitely there's still interest. We just didn't get to it. And then there's also the graveyard draft, which we haven't really talked about much. It hasn't seen that many changes. The changes that people requested were put in, So this is a question to the chairs about what to do with it. Are we going for adoption or are we going to drop it?
I was trying to remember if the graveyard draft is in our charter, but I think it isn't, if I remember correctly. And I think it would be a good idea to probably continue working on that, because I think it would be useful to have a document that says something about that. But there's also a couple of other. We know that there's a couple of drafts that are ready for the last call, working group last call, that we should be starting to get out, and so I think we need to take these all to the list. So if people would set the reminders to the list and saying that okay, these documents are ready and should be going to the working group last call, so we can start it. And for the graveyard document, I think you should talk with the AD first and discuss whether he wants to, whether he thinks it is actually better to have it as an AD sponsored or a working group document, because I think the problem with the working group document is always a little bit slower process, and we are just moving obsolete documents to more historic and so on. It's a little bit more. We have said that we are not doing anything for IKE version 1 in the working group. So if you have any other business, I think you should take them to the working group list. And I think it would be very useful to have. So I think it would be also very good to have interop or interim meeting about the ESP stuff, because I think there is going to be lots of discussion about that. But I realized that it's going to be taking about an hour or so to discuss that. So that's why I think we cut it short here, and I think it would be better to have a interim meeting somewhere to discuss only that or something like that.
Today was just the pitch meeting.
Yes.
Okay. So we've got a bunch of things to do. So with that, I think I can click the terminate meeting button, or just wait for Mitako to shut us down in 5 minutes. Okay, thank you all, and I think we're done here.